Mensuration, the topic which includes diagrams and shapes and the interesting solids which we take into consideration in daily life. So what is mensuration? Mensuration is a topic which includes the most important topics, the connected words which we identify in mensuration as area and volume. The minute mensuration comes into mind, these two are the words which come immediately into the mind, the areas and volumes. So when do we find the area and when do we find the volume is the biggest question in case of the three-dimensional mensuration concepts. What makes me find the area and what makes me find the volume is what we need to understand. So finally, we just try to take some example problems to identify whether the situational problem is related to finding the area or the volume of the given problem. So initially, let me start with the canvas used for making a tent. If my problem is related to the amount of canvas I require to make a tent, then immediately what shoots in my mind is about finding the area, is how I understand the situational problem. The canvas I use for making a tent is related to area, therefore this problem is exclusively used in identifying the area of the given situational problem. Similarly, if I take say gas filled in a cylinder, then immediately this situational problems make me remind of the volume but not the area, because when the gas is filled in the cylinder, we measure it with respect to the volume. When we take the amount of canvas for making a tent, we measure the canvas through the area, is how we need to identify whether the problem is related to finding the area or the volume from examining carefully the given situational problem is very important. So gas filled in a cylinder is identified to be the volume related problem out here. Let's take some more examples in identifying here. Laying down the road or construction of a road is clearly a problem related to the surface, that is area. Or if I take filling up the petrol in the tank is a problem related to volume, because when I fill the petrol in the tank, I measure it in liters, or I say I want 5 liters of petrol to be filled, but I don't say I want this much area of petrol to be filled in the petrol tank. Therefore, laying down the road is a problem related to area. Similarly, filling up of petrol in vehicle tank is nothing but a problem purely related to volume, etc. So this is how we try to understand or analyze or especially visualize on how we can identify the problem for finding its area or volume. Remember, it's very important that mensuration is a topic which includes visualization of objects, because when I say I want to find the length of the bridge or I want to find the area of the complete petrol tank, then I don't assume going out and measuring the entire petrol tank, but I visualize and then take the dimensions to find the respective areas and volumes using the visualization concept. Therefore, this is very important before we start the actual topic of mensuration. Identification of area and volume is the most important concept. So finally, the learning outcome here is that we identify that situations decide whether the given problem is about finding the area or volume. So finally, my learning outcome in case of this session is that it's purely the situations which decide whether the given problem is about finding the area or the volume, is what is the introduction of mensuration connected with area and volume. Now, as we have seen mensuration connected with areas and volumes, now there are so many different shaped objects in this world. So in the universe, you find different shapes which have their own definitive measures. Now say for example, I take the most simplest example of a pencil. I see that it has a sharp object and then the rest of it is flat and then it is bulged in the bottom, or sometimes it might be flat. Now this makes me understand that there are different shapes out here. If I separate the different shapes, I first have this shape out here and then this comes out in this form, and then finally if I separate in this. So these three different objects, when I separate from this, when combined together, forms a pencil, which we most oftenly used for graphing on the graph sheet. So different objects are combined to form a definitive object called the pencil. Now say for example, I take a real life object, say we all know that this is a funnel. So in case of this funnel, I see that I have one of the shape out here which is exactly separated from the other shape here. So my visualization makes me understand that there are two different shaped objects in this combined object. One is this curved surface object, which is called the cone in its mathematical meaning, and the other is a cylinder, which I find here in as the thin part. So a cylinder and a cone makes a funnel is how I understand. To take with the diagram, I have this in the shape of this, so that this funnel when separated gives me a cylinder sort of shape, and then the bottom part gives me a cone sort of a shape, is how I understand the object in its own definitive manner. So there are different objects. Say for example, I take one more object for better understanding of how the combined structures are understood. Now we all know that this is a test tube which we most oftenly use in the biological laboratory, most oftenly. So in the sciences laboratory, the test tubes are used very oftenly, so you're all well aware of this. Now we know that this has a cylindrical surface until here but bulged. That means I have a cylinder and the other part is a hemisphere, which I find because this is part of the sphere. Therefore, if I visualize this object, I understand that a test tube, which is generally flat but bulged in the bottom, makes me understand this can be separated as a cylinder and then a hemisphere, which I get from separating the two objects. So finally, we see that a test tube which is separated into the cylinder and the hemisphere, or a pencil which is separated from the top, the middle and the bottom, or a funnel which is separated with a cylinder and a cone, is how we visualize the combined structures. And separating them and then finding each of the areas and volumes would be easy because each of the cylinder or a cone or a hemisphere have their own definitive properties. Therefore, mathematics in mensuration have identified some standard objects like the cuboid or a cube or a cone or a cylinder, or we have different shapes like pyramids, etc., which are said to have definite areas and volumes. So let's see some standard structures and their areas and volumes respectively.